Hello and welcome to this tutorial in Pre-Stress. In this tutorial we will be going through the structural topping options in the program. The topic for this presentation will be that we add a topping to an element. We will be looking at reinforcement, both longitudinal in the topping and stirrups. And we will be looking at the settings and the special settings for the topping. And we will be looking a little bit about the calculation and results. So let's go into the program. Here I have started to add a T-beam, which is 1.2 meters wide, so we will be adding a topping on top of this. In order to do that, we have to select the topping, and if we have no previous topping in the program activated, we have to add it. And here I can go into the non-standard concrete topping, and any topping used before will be stored here in the section where it says section name. I will though create a new one, so I press add, and I will add a name for it. It should be topping 120 millimeters. Here we can see a preview of the topping, and if we select the double up arrow with a question mark, we can actually see a drawing of what the different measurements mean. I will use a topping that is 600 millimeters on each side, and it's evenly distributed, so TV1 120 millimeters, TV2 0, TH1 120, TH2 0, and the thickness above the element is 120. I will add this and select OK. And now the topping will be stored here, and I just select it and press OK, and it will be here. If I now press add, I now get the wizard that you do for normal elements, but here we now have the option load case topping activated as well. So I start with generating the dead loads, and then we need some load cases. So let's just start with the dead load. We have dead load topping, and we have a live load. The reason that we have different kind of load cases for the dead load and the topping will be because the program actually handles these two load cases differently with regards to material properties, shrinkage, creep, and when we actually apply it on the element. So I will select the dead load topping for the topping and the dead load for the normal beam. We can now see that we in the right part of the element now have the element, the length, the section, and the topping section. And in the left part we can see that this icon means that we haven't applied any topping yet. And the topping will most likely be added in the erection phase of the building. So press erection, and in the further right part here we can see that the topping is set to none, but in the construction phase we set it to wet. When it is wet, it is only considered as a load, while in the coming parts here now it will be cast, and we will have the structural topping acting on the element. And we can now see that the icon here shows that we don't have any topping at first. We have the wet topping in the erection phase, and we have the cast topping in the further phases. If you want to change the properties of the topping, there is now a tab up here that's called material topping next to the material. If we don't have the topping, we only have the material tab. So the material topping will only show up where we have the topping. And this is similar to the materials that you define exposure class, life class, strength class, and so on. I will not go into further changes if you want to change the strength class, so we just use this one. If we take a look at the element, we now have a few options for the reinforcement. We have the normal layer of reinforcement button here, where I say 2 reinforcement bars in the top and 5 in the bottom. But we also have the layer of reinforcement topping here. So by pressing that, I can say that I have 2 reinforcement bars in the top of the topping, and I have 2 in the bottom of the topping. And maybe it shouldn't be the strands, but just the something like that. And we now have the reinforcement bars in the top, in the topping, and the bottom of the topping, and also in the beam. As for stirrups, we can define the normal stirrups in the beam, and we can actually see this position that it is in the beam. But I can also define a new group, and this is red because it's overlapping. But if I choose the position topping and I select another spacing, it will actually be okay. And if we go now to the first here, we can see the normal reinforcement in the beam, and we should be able to see the reinforcement in the topping, which is actually connecting the beam with the topping. So any reinforcement that we see will be the area that's actually going through the joint here. Reinforcement details, nothing in particular. Calculation settings. Here we have one new option called the topping joint, where I can say that the surface is very smooth, rough, or indented according to Eurocode. For this example, I will set it to rough. We have no fire in this example, and the calculation sections are looking good. And that is basically the geometry. And we move on to loads. Here we can now see the loads, and this is the dead load of the beam. We have the dead load of the topping, and since we said that it will be applied in the erection phase, the load of the topping will be added from the erection phase and forward. And as for the live load, I will just add the load. And there is one more option now in the load combination, and that is the long-term parameters for the topping. And if I have a creep coefficient of 2 and 0.2 for instance, and this will only be applied in the final stage because storage and maturing is actually before we apply the topping. While in the other phase here we might have a little bit different settings. And I will come back to you in a short while I have created all these load combinations. And here I am back, and I have now filled in all the load combinations. And as we can see from the erection phase, I have the B2 factor, which is the dead load of the topping as well, filled in here. We swiftly move on to the calculations, and there is nothing special that we have to apply in order to take into consideration the topping. And in the design, let's make a code control, and we can see the code checks. And in the ultimate limit state, we now have one more option called topping joint capacity, where we can see the force in the joint compared to the capacity of the joint. And that can be seen in the first section, but we also have the table bending of the topping in the ultimate limit state, where we can see the moment capacity of the beam with the topping and the utilization, and also some parameters similar to the normal beam. While in the table shear topping for ultimate limit state, we can see that we have the F joint, which is the force in the joint, and that should be basically 0 in the middle and highest at the ends. We have the FRD, which is the capacity of the joint. We have the width of the joint and friction parameter, and also the area of the reinforcement that we have applied and that we need to add as a design. And that basically concludes the topping tutorial. Thank you for watching.